tanan. Okay, again, our lesson for this morning, we have atoms, molecules, and also ions. So we have the following objectives for this lesson. Describe the structure of an atom and its composition. Determine how elements are grouped together according to their chemical and physical properties in the periodic table. And then discuss how most elements interact to form compounds, which are classified as molecules or ionic compounds made of positive and negative ions. So we call the positive ions as cations and negative ions as anions. And lastly, identify how to use chemical formulas, molecular and empirical, to represent molecules and ionic compounds, and models to represent molecules. So again, those are our learning outcomes for this topic or for this lesson. Okay, for our topics, we have the following. We will talk about the atomic theory, and then the structure of the atom, and then again, as in, though we are done with this laboratory, we will still discuss atomic number, mass number, and isotopes. And then we will also discuss the periodic table, molecules and ions, and chemical formulas. So, yan. That's it for our topics. Now let's start. Let's start with the atomic theory. So basically, when you say atomic theory, we will be talking about the history of the discovery of atoms. So ano ba yung mga alam natin about atoms nowadays? Ito yung start niyan. Okay, so the first one, the first name here is Democritus. Again, that's the first name, Democritus. He was a Greek philosopher during 15th century BC, and he was the one who coined the term atomos. Again, he was the one who first used the word atomos. And what is that? What is that atomos? It was actually described by him as very small, indivisible particles na nasa matter natin. So lahat daw ng matter, di ba, matter, anything that occupies space and has mass, but matter daw is consist of these small, indivisible particles which he named atomos. So ang meaning ng atomos that time is uncuttable or indivisible. Yan yung pinaka-description ni Democritus. So sa kanya nag-start na meron tayong concept ng atom, which is the building block ng ating matter or the basic unit. Now, experimental evidence from early scientific investigations provided support for the notion of atomism and gradually gave rise to the modern definitions of elements and compounds. So it started with Democritus, but nevertheless, the succeeding experiments showed or revealed that yes, indeed, there is the presence of these small particles na nasa matter natin. So that's what they call atomism. And further discovery ayon gave rise to what we know nowadays as the elements and the compounds. So after class kay Democritus, we have another name here, John Dalton. He was an English scientist at the same time as school teacher. So ano yung ginawa niya? He formulated a precise definition of the indivisible building blocks of matter that we call atoms. Kasi nag-start lang yon kay Democritus, sabi niya basta merong indivisible particles. But for the definite class na description of what atom is really is, it was John Dalton who made that description. So for the work of Dalton class, let's summarize his work. Mao ni ang iyahang trabaho sa iyahang experimentation nga gibuhat sa iyahang mga investigation. So at the end of the work of John Dalton, these are These were his theories. Number one, elements are composed of extremely small particles called atoms. Remember, our elements are the simplest form of matter, and that elements, though it is the simplest form of matter, it is also composed of smaller particles which he called atoms. So I hope nakuha nyo yan. Again, he called the components of the elements as atoms. And then, all atoms of a given element are identical. They have the same size, shape, and chemical properties. So pag sinabing hydrogen element, lahat ng hydrogen elements sa Earth class only has the same type of atom, and that is the hydrogen atom. They do have the same sizes, even the same mass, and the same chemical property. So basta isang element, identical lahat ng types or characteristics ng atoms niya to all other elements na the same ha. So hydrogen and all the hydrogen. But when you say ibang element na siya like oxygen, iba na din ang characteristics ng atom niya. So again, the atoms of one element are different from the atoms of all the other elements. That's the second theory of John Dalton. And then number 3, compounds are composed of atoms of more than one element. So the element, again, is the simplest form of matter. However, this element can combine, can make bonds with each other. Mag-combine sila to form a compound. Again, pag atuan ng isagol-sagol ato ang element, pag magkaroon na sila og bonding, we call them now compounds. Now, take note, sa mga compounds natin, the ratio of the number of atoms of any of the two elements present is either an integer or a simple fraction. So, let me give you an example. So, we have the compound here, example, water. So, this one is a combination of two types of element, that is hydrogen and oxygen. But to form this kind of compound, kailangan kasi definite ang ratio ng kanilang pag-combine. Pwede siyang integer or whole number, or pwede din siyang simple fraction. But this time for water, it needs two molecules of water and one molecule of oxygen, or two atoms of hydrogen and one atom of oxygen. That's the ratio para makagawa tayo ng compound na water. So that is again for the compound. Now number 4, lastly, this one is the theory of John Dalton. A chemical reaction involves only the separation, combination, or rearrangement of atoms. It does not result in their creation or destruction. So according kay John Dalton, ang ato-atong mga elements, atong mga atoms, they can combine with each other, just like when you combine an atom of sodium with an atom of chlorine, you will get what we call table salt or asin, the sodium chloride. But we can also separate them. So we have here a compound, and then we will be separating their atoms na components. So you will still get the sodium and the chloride. Or pwede din magkaroon ng rearrangement. So for example, you have water plus carbon dioxide. Although mag-combine lang gihapon na siya class, pero we have here a rearrangement. This will become H2CO3. H2CO3. So there is rearrangement of the atoms there. From the water, there is combination at the same time, rearrange, maging H2CO3 siya. That is carbonic acid. Pero yung chemical reaction natin hanggang separation, combination, and rearrangement lang sila. Wala tayong chemical reaction that will result in the creation of new atom or the destruction of the existing atom. Kaya kung nakita ninyo, you have Na there, Cl, pag abot sa product niya, you can still see the sodium and the chloride. Walang new atom na na-form and wala ding original atom na na-destroy. So I hope that is clear sa inyo ha, nga pag chemical reaction, again, kung unsa lang ang naa sa original na composition, mao lang pud inyuhang makita sa product. Questions so far about this concept ni John Dalton? Anyone na wala ninyo na confuse mo? Klaro man na, no? Mo na siya ang work ni John Dalton. So, gikan sa work ni John Dalton, class, we now have the following laws. Again, this is from the work of John Dalton. The following laws were formulated and accepted. So, number 1, we have the so-called law of definite proportions. Again, law of definite proportions. From the name itself, definite. Meaning, anak class, our elements combine with other elements to form compounds, but they do so in fixed ratio or fixed proportion. So actually, na-mention ko na siya kagaina, para makabuhat ta og water, kailangan na to og 2:1. Dalawang hydrogen, isang oxygen. So mo na naatay H2O. This is fixed class before ka makabuhat og kani nga compound. Pag mayroon kag water, fixed gina siya. Duha ka hydrogen, isa ka oxygen. So that is what you call law of definite proportion. So the ratio of masses of different elements in a given compound is fixed. The ratio of the atoms of this element in the compound also must be constant. So, constant na siya pag muingon kag water. Or kung muingon kag, I want sodium chloride or the table salt. Fixed din siya, class, na you just need 1 sodium here and 1 chloride. Again, to make a table salt. So, definite ang proportion. Pag nag-iba, class, ang proportion, it means it's already a different compound. Parehas anang duha ang hydrogen, tapos duha po ang oxygen. This is not water anymore. This is already hydrogen peroxide, or that's what we call the agua oxinada na ginagamit natin as antiseptic. So, definite ha ang proportion. Pag nag-iba ang proportion ng mga atoms sa isang chemical formula, it means it's a different compound already. That's law of definite proportion. Now, the second law na-accept, na-formulate and na-accept from the work of John Dalton was the law of multiple proportions. Again, law of multiple proportions. So, daghan kay nakasulat sa slide, pero sige, let's read it and then afterwards, let's have an example para mas dali siya masabtan. So according sa law of multiple proportions, if 2 elements can combine to form more than 1 compound, the masses of one element that combine with a fixed mass of the other element are in ratios of small number. And then different compounds made up of the same elements differ in the number of atoms of each kind that combine. So, ang ginamin-an ng multiple proportions, class, kay 2 or more elements can combine, pero pwede sila lahi-lahi og proportion para mag-combine po og lahi-lahi nga compound. So for example, you have carbon and oxygen. Carbon and oxygen can combine to give you carbon monoxide. So for carbon monoxide, the ratio here is 1:1. But nevertheless, you still have carbon and oxygen. That's carbon monoxide. And then, we can also combine carbon and oxygen with a different ratio. This time, we have 1:2. So carbon, 1 carbon, and then 2 oxygen can give you carbon dioxide. Ayan. So, ang sabi ng law of multiple proportions, the elements can combine. Again, pwede sila mag-combine at different na proportions or different na ratio to give rise to different compounds like this one. Carbon monoxide and carbon dioxide are two different compounds, but pareho sila na they have carbon and oxygen. Actually, applicable gihapon tong kagaina, H and O. We can combine H and O in this proportion. So, duha ka hydrogen, isa ka oxygen, but this time it is water. Pag nahimo na siya og H2O2, this is 2:2, we call this now hydrogen peroxide. Okay? Unang ginaingon sa law of multiple proportion. So, dili bawal class nga pag nagamit na ang isa ka element and then another element na anay compound na form, dili na nimo sila pwede gamiton na in different proportion. Pwede gihapon, pero lahi na to siya na compound. That's law of multiple proportions again. Okay? Questions? Nakuha ninyo ang difference ni law of definite proportions ug law of multiple proportions? Ang definite class, pag moingon kag compound, pag water, H2O lang yun na siya. Dili pwede magbago ang iyahang ratio. Duha ka hydrogen, isa lang yun na siya ka oxygen para makaingon kag water. That's law of definite proportion. Pero pag moingon kag law of multiple proportions, kaning atong mga elements, pwede ra kayo sila mag-combine in different ratios para mag-form pud ka og different compounds. So, muna siya example, carbon monoxide and carbon dioxide. And lastly, we have here the law of conservation of mass. Again, law of conservation of mass. So, unsa man ni siya na law? This states that matter can neither be created nor destroyed. So, muna ang work ni Dalton kagaina. Ingon siya, pwede lang ma-separate ang atoms, pwede po sila mag-combine, pwede sila mag-rearrange, pero wala kay new atom na ma-form, wala po kay existing or old atom na ma-destroy during chemical reaction. So, ang mga atoms na ni class, when they undergo chemical reaction, they remain unchanged. So, muna siya ang law of conservation of mass. So, for example, you have the acid hydrochloric acid. Tapos, gipa-react na to siya with sodium hydroxide. During the reaction, sodium chloride and water, I'll just write water as this one ha, para di mo magbibog, and water ang ma-form. So, kung nakita ninyo, hydrogen is still present, chloride is still present, the same thing with sodium and even the hydroxide. So, no new matter is created, at the same time, wala ding na-destroy. That's law of conservation of mass. So, the masses of the atoms there remain the same. Parehas lang gyapon ang protons din ha nga naa sa tibuok chemical reaction, the same lang, walay na-destroy, walay bag-o nga na-create. That's law of conservation of mass. Questions? Nasabtan pa so far? Nakasunod pa so far? O paspas rakay ko? Kasi paspas rakay ko class. Okay, nawalahin na biya sa section B. Na Shakira ko sa section B kay nahuman na sila o naming and inorganic. Oh, grabe sila. Paspas kayo. Anyway, let's try to habol. Pero, let's see. Pag dili ganin ako na mahabol class, dili lang nato to ipilit o appeal sa inyong prelim nga exam. Sa sunod na lang to, sa midterm na lang to, dili na to ma-discuss. Bahala na ang section B kung nauna na sila. Actually, ang section B, kilahi man sila teacher, so medyo nagpaspas sila dito. Kamo sa section C, sabay-sabay lang mo kay parehas mo teacher. Ako man yung teacher. Nauna lang yun ang B. Sige, what is this topic about? Dalton's brilliant insight into the nature of matter was the main stimulus for the rapid progress of chemistry during the 19th century. Though si Democritus class ang first naggamit sa word nga atomos, pero it was actually the work of John Dalton who paved the way para magkaroon og daghan pa nga investigation about the existence of these atoms and all the reactions involved. So mo na karon nga daghan na tag nabalan about these very small particles that we cannot even see using our naked eye. So kana gyud si John Dalton diha gyud na siya nag-start. Okay? Sige. So let's talk about the structure of the atom. Do not forget that when you say atom, this is the basic unit of matter. And atoms are actually the ones nga naga-enter into chemical combination or chemical reaction. Now let's talk about the components naman of the atoms. The atoms are not really kanang what do you call that? Dili sila jud indivisible because they contain subatomic particles. So we have here, you are very familiar with this, the protons, neutrons, and electrons. They are the subatomic particles. P there for proton will tell you that it is the positively charged, and N for neutron is a hint for you that it is neutral, it does not have charge, and electron syempre is negatively charged. Again, these are our subatomic particles. Now, for the structure of the atom contains nucleus class. Again, atoms have nucleus. When you say nucleus, it is a small na dense part of the atom wherein we can see protons and neutrons. But nevertheless, it's a positively charged region in the atom due to the presence of the protons. So again, ang makita sa atong nucleus, it's the neutrons and the protons. And then outside the nucleus, so the nucleus is actually surrounded by the negatively charged particles, our electrons that are actually constantly moving. The electrons are moving class. So we have class the electron shells for that. Dira nato makita si electrons. Wala namang nakaabot og siniskwela, no? Nakaabot pa ba inyong generation ng siniskwela?
Nakaabot, ma'am.
Ikaabot, ma'am.
Nakaabot.
Yes, ma'am. Favorite kayo na ako na.
Favorite kayo na, ma'am, as in.
Okay, so nagkaabot pa di ay ang inyong generation sa siniskwela. Wala namang good siya karon. Pero di ba, you can see this sa kanaganing sa music nila sa siniskwela before mag-start. Diba na ingani, murag ingani nawong sa ilahang sa screen nga na nagadagandagan, that is actually the electron. So atom na siya, and then na nag-move na small one, a small particle, that's the electrons class. Okay, so let's talk about atomic number, mass number, and even the isotopes. So humanataan ni sa sa laboratory, pero I hope wala na ma-confuse ha pag moingon kag atomic number. Unsa gina-represent niya? The number of
Protons.
Protons.
okay, very good. The number of protons. Pero inyong tandaan, pag pag walay charge ang proton, the same lang walay charge ang proton, walay charge ang element, the same lang ang number of protons ug number ni electrons. So that's the atomic number, atong hint din ha. Pag magkaroon og charge si element, mahimo siyag ayon, mao na ang time nga dili na parehas ang number ni protons and ni electrons. Again, that's the atomic number. So duha man na sila ka number inyong makita din ha sa inyong gibuhat na periodic table. We have the atomic mass. Other name for atomic mass is mass number. Pwede po siya tawagon og atomic weight. Again, atomic mass, mass number, or atomic weight. The mass number is most of the time larger. Larger ha, mas dako siya kay atomic number because duha ka buok nga subatomic particles iyahang gina-represent. So mass number represents both neutrons and protons that are actually present again in the nucleus. So kana para dili mo ma-confuse. Ang mas dako nga number, that's the atomic mass or the mass number. So paano na to ma-identify karon ang isa ka atom? Actually, the atoms are identified sa ilahang number of protons and even sa ilahang neutrons. Because the atomic number does not change kung pila kabuk iyang protons, maugid na iyang proton. So pag pangutanon mo unsa nga element ang naay isa ka buok nga proton, wala na gyud laing answer din ha, hydrogen lang gyud na siya. Kasi si hydrogen lang ang 1 iyang atomic number, so mo na isa lang pod iyang protons. That's the same thing pag buingon ka unsa nga element ang naay duha ka protons, that's the helium automatically. Again, ang kanang number of protons ginagamit nato na siya as pang-identify kung what element is present. And lastly, we have there the isotopes. Later, we will dig deeper about isotopes class, but to give you an overview, when you say isotopes, they are atoms that they have the same atomic number. Again, they have the same atomic number, which means the same sila nga element. Okay, the same man nila atomic number. But what is their difference here? They have different mass numbers. So let's talk about that later. Let's have first the atomic number. This is the number of protons in the nucleus of each atom. So just like in the example, you have there fluorine 9 and atomic mass is 18.998. 9 din ha class, mauna ang atomic number. And it means that fluorine has 9 protons. Okay? But in a neutral atom class, in a neutral atom just like this, fluorine has no charge there. The number of protons is equal to the number of electrons. Okay? So pwede po nato gamiton si atomic number to know the number of electrons sa atuang atom. Pero kailangan nato tandaan nga dapat walay charge. Wait lang ha, kadjut lang jud. I'll be back 1 minute. Okay, let us continue. That is for the atomic number ha. Again, the symbol for our atomic number is Z. Okay, next we have the mass number. Please ask questions if you are not, if you are confused ha, about something. So we have here mass number. The symbol is capital letter A. Do not forget, ang gina-represent ng ating mass number kay ang number ni protons and at the same time ni neutron. So duha ka buok mo na nga always gid na siya class larger ang mass number or ang atomic mass. But take note that protons and neutrons are collectively known as the nucleons because these two subatomic particles are found inside the nucleus. So ginatawag sila collectively as nucleons. But they are represented by the mass number or the atomic mass. So again, mass number is equal to number of protons plus number of neutrons. Or actually, that's the atomic number. Kay mo man ang gina-represent sa atomic number, ang number of protons plus the number of neutrons. Una class, pag gusto na ito mabalaan ang number of neutrons, so neutrons is equal to atomic mass or the mass number minus the atomic number. Again, that's our formula to know the number of neutrons. And it's the mass number, huh? Okay, so we have here the number of neutrons in an atom again is equal to the difference of the atomic mass and the atomic number. So for example, ang boron nato class, si boron, do humanataan is atong laboratory, boron is 12.5. So 12.5 na siya, meaning the larger one there is the mass number, the 5 there is the atomic number. So if we want to get the number of neutrons, then this is just 12 minus 5, which is 7. That's the number of neutrons for boron. So take note that all three quantities, the atomic number, the number of neutrons, and the mass number must be positive integers. And most likely, we will use the whole number. So class, for the atomic mass of the elements, please round them off to the nearest whole number. Sa inyong mga assignments, sa quizzes nato, or sa exam, you have to round off the atomic mass or the mass number to the nearest whole number. I hope that is clear. Okay. Next, we have here now the isotope. So you listen kay wala na to ni gi-appeal og discuss sa laboratory. So unsay meaning sa isotopes again? They are atoms na naa sila same atomic number, so the same. You have like for example duha ka atoms. Example ha, duha ka atoms. So the same ilahang atomic number. Kung the same ilang atomic number, ang meaning ana they have the same number of protons. Okay? So, unsay meaning ana pag the same ilang number of protons, they are actually the same element. Again, they are actually the same element. Paano siyang ginamin sa same ang atomic number? Same ang atomic number, therefore, the same ang number of protons. And remember that the protons are actually used to identify element. So, kung the same ilang number of protons, the same sila na element. But what is different with these elements? They have different mass numbers. Nganong different ilahang mass numbers, class? Kaya they have different number of neutrons. This is the reason why they have this different mass number. So I hope nasundan na siya. So ang tawag nato sa ilaha kay isotopes. So tagaan ta mog example, we have here, class, we have 3 isotopes of hydrogen. Meaning ana pareha sila tanan hydrogen. So meaning pareha sila tanan na ilahang atomic number kay 1. And that they have 1 proton also. Okay? So unsa ni sila? We have here, take note sa baba, the hydrogen. That is the most abundant na isotope ni hydrogen, si hydrogen mismo. 1 iyang atomic number, 1 po diyahang mass number. Tapos, ang isa ka isotope ni hydrogen is called deuterium. Unsay nalahi? Diba, ingon ko, pareha sila atomic number. So, 1 lang gihapon yung atomic number, pero this time, 2 na iyahang atomic mass or iyahang mass number. Nganuman, kay naa na siya'y neutron. Sulat na to, this is proton, electron, and neutron. So for proton here, for hydrogen, you have 1. Electron, syempre, you have 1. Pero neutron, you have 0. Wala na yung neutron pag maingon kag hydrogen, kay 1 minus 1. But this time, for deuterium, you have still 1 proton. You still have 1 electron, but for neutron, 2 minus 1, naa na siya isa ka neutron. Again, we call it deuterium, but this is still hydrogen here. Ang tawag lang sa iya deuterium, or this is what we call the heavy hydrogen. Ayan. Mag-form po na siya, di ba? Hydrogen is used to make water. So this is water here. Kanang water na to, that's H2O. Pero napunta ginatawag og B2O class. This is what we call the heavy water. So pag heavy water ganina siya, it is made up of the other isotope of hydrogen called deuterium. So muna gitawag siya heavy water. So asa nato makita ning heavy water? Kanang water nga to ang ginainom, that is actually hydrogen lang siya. The original hydrogen. Actually ang tawag na to aning hydrogen na ni is protium. Again, this is called protium. So asa nato makita ang deuterium? Makita nato na siya sa dagat. Sa kanaganing mga kanang lalom na kayo nga part sa dagat, daghan na siya dira og deuterium. So for some cases, usahay na pud tay water nga na ay heavy hydrogen, pero if less lang ang amount nga atong mainom, actually dili jud siya toxic. I mean, dili siya makadaot sa lawas if gamay lang atong mainom na deuterium. Pero ang makadaot class kung naglaklak na ta og heavy water or deuterium na water, that is already bad sa atuang health or sa atong body. And ang dili gyud nato gusto kaning ikatatlo, the tritium. So isa gihapon iyang proton, iyang electron kay isa gihapon, pero iyang neutron 3 - 1 duha. So si tritium class, this is our radioactive hydrogen. Radioactive hydrogen, meaning naga-emit og radiation. So that is why dili dapat nato inomon kay naay radiation ni siya nga type sa hydrogen. So ano ni siya actually? Kaning tritium is a byproduct of kanang mga activities involving mga nuclear energy, mga nuclear bombs, mga nuclear plant. Ano na sila? Kanang byproduct, mabuo dira ang hydrogen called tritium. And radioactive again. So dili pwede nga inumon nato na siya. Ang ginainom lang yun nato klase protium or si hydrogen mismo. Pero silang tanan ang tawag nato sa ilaha kay isotopes, meaning they are the same element, they have the same atomic number, pero lahi-lahi sila og mass number kay lahi-lahi ilahang number of neutrons. Okay? Questions about this one? Ano siyang meaning sa isotopes ha? Hydrogen ang pinaka example for that. Walay pangutana, mata pa mo diha o natulog na mo?
Wait ma'am.
Mata pa. Sige. So let's move on. We have here the periodic table. So for the periodic table, we have here syempre the elements that are being grouped together either vertically or horizontally. So pag vertical, syempre groups atong tawag or family. Pag horizontal, we have the period. So ang mga elements that are grouped together into one group, most likely they share the same properties, either physical or chemical. So let's have a review. So humanataan ni gahapon no sa ato ang post lab. 'Di ba? Ang sa gani pag vertical, like halina kay Ruby session francium, we have group 1 here. So ang tawag nato ana kay groups or family. Kaya be magka-Cerbera, that's group 2A. Group or family gihapon na siya. Vertical na arrangement. Pero pag horizontal, like going there, that's 1. And then we have here the 2, period 2. That's the horizontal arrangement of the elements in the periodic table. We call this as period. Okay? So again, they are grouped according to similarities in their chemical. This one is, by the way, an old version of the periodic table. So dili pa siya kompleto. Remember na siya dira hangtod 118. So this one is an old pa. Katupa to before 2016, but nowadays we have completed this already. All the 118 elements have been named already. They have discovered also the properties, both physical and chemical properties of these elements. Now take note, naka-color coding tayo class. The green ones are the metals. You need this one especially this afternoon that you will have activity number 4. Kailangan ma-identify ninyo asa ang metals, asa ato ang mga metalloids, and asa dapit atong mga non-metals. Kasi sa naming, mag-differ na sila. Even sa pagbuhat sa chemical formula. Okay? So again, next, we divide our elements and kani dili ni siya sa groups or sa periods. We will just divide them according to whether they are metal, non-metal, or metalloid. So take note, tanan na naka-green, they are all metals from lithium, padulong kay bismuth, and even ang tuang mga elements sa ilalom, the actinide and the lanthanide series, they are all metals. And when you say metals, ang pinaka-characteristic nila is they conduct electricity. They conduct heat and electricity. Now, kanang mga naka-blue, syempre si hydrogen is included there. And syempre we have carbon until the noble gases. They are non-metals, thus they are not really conductors of heat and electricity. And the pink ones from bismuth hangtod sa 117th, I think that's the tennessine there for the 117th. They are our metalloids, or we call them semi-metals. So they have like properties na the same with the metals. They also have the same properties with the non-metals. So we cannot really include them sa metal or sa non-metal. So we make a new classification, and that is the metalloid or semi-metals. Okay, that's how we divide our elements. Now, on Earth and in living system, this is how the elements are being distributed. So ang pinakadaghan din ha class kay si oxygen. Pero ano lang ha, limited lang ni siya dinhi nga elements ang nakalista. Pero what do you think is the most abundant element sa Earth? Who knows here? What is the most abundant?
Oxygen.
Okay,
Oxygen, ma'am.
Very good, oxygen. Sa ikaduha. Again, limited lang na nasa list ha. Sa ikaduha.
Carbon.
Wait lang. Ang oxygen, metal, non-metal, or metalloid?
Non-metal.
Non-metal.
Metal, ma'am.
Non-metal, ma'am.
Non-metal. So, ang pinakadaghan nga element sa Earth class is a non-metal, and that is oxygen. Ang number 2, I'll give you a hint. The second, no, the second most abundant element is a metalloid.
Carbon.
Metalloid. Limited lang itong metalloid.
Helium, ma'am.
Balikan na to. Asa dapit na itong metalloid? Bismuth, silicon, germanium, arsenic, antimony, tellurium.
Silicon, ma'am.
Okay, very good. The answer is silicon. The second most abundant element sa Earth, kay metalloid na siya, it's the silicon. So, what is the third one? Hantod lang to third ha. The third one class is a metal. So, nakapasunod na sila. Non-metal, metalloid, o metal. So, what do you think is the third most abundant element?
Iron, ma'am. Aluminum.
Hula lang to ba? Pero the correct answer is aluminum. Again, the correct answer is aluminum. So pagpangutanon mo class, again ha, ang most abundant kay oxygen, followed by silicon, followed by aluminum. Pero pag ang pangutana, what is the most abundant metal sa Earth? Siyempre
Aluminum.
Siyempre, aluminum, ha? Pag ang pangutana specific sa metal, ang pinakadaghan class ng metal na nag-exist is ang aluminum. So, I hope that is clear. Wala bang guna diri sa table. Kani magod mga elements lang ni nga essential sa human body. So, wala diri si silicon ug si aluminum. This is for the human body here. Okay? Sige, let's move on. Elements are often referred to collectively by their periodic table group number. So, always good na siya. Dapat makabalo po saan na sila nakabilong. Group 1A, Group 2A, and so on. So, pamaingon ka Group 1A, though humantaan ni sa lab, no? Group 1A is called again as alkali metal. So, that is hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. I'm not asking you to memorize the arrangement of elements in the periodic table, ha? Wala ako gipa-memorize gikan hydrogen pasunod. Wala ko na siya ginapahimo sa medtech. Sa pharma ginapahimo ko na siya. Sa medtech wala. Now, group 2A is called again alkaline earth metals. That's Bemagga, Cerbara, beryllium, magnesium, calcium, strontium, barium, and radium. Group 3A. Ano sa pangalan sa Group 3A again, class? Ano sa pangalan sa Group 3A? 3A ha, 3A. Wala dira sa... Okay, very good. Group 3A is called the boron group. So, di ba? Boron, aluminum, and so on. Tapos, unsay sunod? Group 4A. Unsay tawag sa Group 4A?
Carbon, ma'am.
Carbon group, ma'am.
Okay, very good. Carbon group. Tapos group 6A. Unsay tawag sa group 6A?
Chalcogen group, ma'am.
Chalcogens.
Chalcogen. Nag-jump ko ha, 6A to. Chalcogen, that's the group of oxygen. Pero ang group 5A, unsay tawag?
Nitrogen, ma'am. Nitrogen group.
Nitrogen group, ma'am.
So ang group 8A, unsay tawag? 8A. Huh? We have the
Noble gases, ma'am.
okay, very good. Noble gases. And then ang 7A atong tawag sa ilaha kay halogen. So most likely they are being called by their group names. Mga representative elements na to na. Pero ang kanang nasa to nga class from scandium, I think, nasa to nga, we call them transition metals or transition elements. Okay? So let's define the following molecules. Unsa ba meaning sa molecules? Usahay nagagamit tag atoms, usahay nagagamit tag molecules. So ang atoms, class, do not forget that they are the basic unit of matter. But when you use the word molecules, you are actually referring to aggregates of atoms or combination of two or more atoms, meaning two or more, kaya man pwede mag-combine ng isa. So at least two atoms na nag-combine and they are arranged together and held together by a chemical force. And that chemical force is called the chemical bonds. So matawag lang na siya again og molecule if mahimo na siya combination of two or more atoms. So for example, pag ingani lang, sodium atom lang na siya. Pero another example, if hydrogen atom, kay isa ram na siya. Pero if this becomes H2, this is now called hydrogen molecule. So we have two hydrogen here combined together by a chemical bond. So hydrogen molecule, at least two atoms held together by a chemical force called chemical bonds. Now we have class types of molecules. Molecules, when you say monoatomic molecule, again, molecules. Monoatomic, pag mayroon kag monoatomic molecules, they are molecules containing more than two atoms. Again, more than two atoms. Pwede siya atoms of the same element, as in ozone, like O3. Pag mayroon kag O3, we call that ozone. So it has 3 atoms there of oxygen. Pero more than 2. Again, more than 2. Pag ginatawag siya monoatomic molecule. More than 2. Wala na siya. Nagbasing na-confuse mo mono. Di ba ma'am, pag mayroon kag mono, isa lang man na siya. Pero when you say monoatomic molecule, these are molecules that contains more than 2. The key there is more than 2 molecules. Whether it is the same element or combination of 2 or more different elements. Like sa water, you have there 2 types of elements, hydrogen and oxygen, and 3 atoms to be exact, kay duha ka hydrogen. So more than 2 atoms na siya. It is called a monoatomic molecule. Same thing with ammonia. Now, ang ikaduha ka klase nga molecule is called diatomic molecule. So unsa pud ang meaning anang diatomic molecule? Pag mayroon kag diatomic molecule, they contain only 2 atoms. So basig magbaliktad pag di ha, ang di nagasunod gyud ta nga naa siya duha ka atoms. So like this one, nitrogen, so duha ka atoms lang, oxygen, duha lang pud ka atoms na O2. And then pwede pud siya different elements, class. Again, pwede pud siya different elements as long as duha lang gyud ka atoms, like hydrochloric acid or the hydrogen chloride, HCl. Duha ka atoms lang na siya. Isa ka hydrogen, isa ka chlorine. And also carbon monoxide, isa ka carbon, isa ka oxygen. So basta duha ka atoms nag-combine together, we call it diatomic molecules. And then monoatomic molecule kung more than 2. So 3 or more, we call them monoatomic molecules. By the way, yes, tama ni siyang gisend. Kita ito nag-send ulit. So tama ni siyang gisend ni Kim na atay gamit na mnemonics for the diatomic molecule. This is again for diatomic molecules, but kaning the same element. The same element. We have here the Birchnow. I don't know if you are familiar with that. Sometimes I call this as Birchnow para dili maglibog. Kay usahay pag Birchnow basig moingon mo boron, ma'am. Kay B is boron. So say ginabutangan ako na siya R sa tunga, Birchnow akong tawagan na para it's for bromine. Okay, it's for bromine. So mao ni sila class ang mga elements that they exist as diatomic molecules in nature. So we have the bromine, iodine. This one is actually the chlorine, hydrogen, nitrogen, oxygen, and fluorine. So muna usahay class, magtanaw mo og chemical equation, you cannot see like oxygen nga O lang. Most of the time, na gina siya 2 dira. Kay oxygen exists as diatomic molecules in nature. So sila na mo ni sila mga elements, Birchnow, bromine, iodine, chlorine, hydrogen, nitrogen, oxygen, and fluorine. Questions so far? Namoy wala na sabtan. So let's talk about now about ions. We have here, syempre, pag ang atom class nagkaroon og charge, mahimo na siyag ion. Pero the reason why magkaroon na siyag charge is either nag-lose siya og electron or nag-gain siya og electron. So we have 2 types of ions, the positively charged and the negatively charged. So the first one is positively charged. The P there will give you a hint that this is the positively charged. So nganong mahimo man na siya positively charged? Because nag-lose siya og electron. Una nga mas daghan iyahang proton. Okay, pag nag-lose og electron, mahimong positively charged. Pero pag mag-gain og electron, it becomes negatively charged. We call it an ion. So nag-gain man siya, so meaning mas daghan iyang electron mo na nga negatively charged siya. Okay, another way of classifying our ions, we have the monoatomic ion and the polyatomic ions. Pag moingon kag monoatomic, mono means one type of atom. Okay? So for example, sodium ion. Isa lang siya kaklase, sodium lang yun siya. Or chloride ion. That's still one type of atom or one atom. Yahang gina-contain. Or pwede po magnesium ion. Or iron na ion. Tongue twister to iron na ion. Okay, iron ion. Fe3+. Okay, so nahimo nag-ion si iron. Kaya na siya ay charge. But nevertheless, monoatomic siya. Kaya isa lang siya ka-atom. Pero, pag combination na gani siya of different types of atoms tapos na siya charge, ang tawag na nato ana kay polyatomic ion. So, na ako yung assignment sa inyo ha. Pero dili na ninyo kailangan ipasa. Your assignment is to make an index card listing the different polyatomic ions that we have na nag-exist. Again, ilista ninyo sa isa ka index card, tanan polyatomic ions nga nag-exist. How do you write that sa index card? You write here the name, for example, naka-table, and you have there the symbol. Or not the symbol, the formula. So, like this one, OH negative. Isulat ninyo diri OH negative. How do you call OH negative? We call that as hydroxide. So again, class, remember, polyatomic ions are not really considered as compounds. Kaya pag maingon ka compounds, wala na siya ay charge. Ang similarity lang nila sa compound, kay combination sila sa two or more atoms or elements, pero kanina manggod na siya charge. And then another example, Cn negative, mo na yung formula na siya charge ha, -1. We call that cyanide. So pangitaon na ninyo karon, i-research ninyo ang different polyatomic ions that we have. Or tagaan pa tamog isa, NO3 negative na agihapon siya charge. This is what we call the nitrate. Or pag NO2 negative, we call that the nitrite. Okay? So sa naming class, the ite and the ate na ending is only applicable for polyatomic ions. Okay? Polyatomic ions lang nato na ginagamit si ite o si ate na ending. And ginatanaw nato ni sila based sa number of oxygen. The lower number ng oxygen should end with ite, and the higher number sa oxygen sa formula will end with 8. Just like the example, nitrate and nitrite. Nitrate is NO3, so mas daghan siya oxygen. Si nitrite kay duha lang iyahang oxygen. That's the time we use the ending ite and 8. Applicable siya sa polyatomic ions. Okay? Any questions so far? Wala? Wait lang ha. So, oops. Ayan. Kanina din ang next. Okay. So, let us now move, class, sa mga charges. Sa atong mga ions sa periodic table, let's see their charges. Kailangan nato ni siya mabalaan kay para sa laboratory, it will be easier for us to write the chemical formula. So this is class the periodic table. Let's not just deal with the actinide and the lanthanide series since they are rare earth metals. We seldom see them sa atong mga compounds. Dili lang sa atong mga common. Again, sa mga common nato na elements. We have this here. Though we can actually include hydrogen. Let's just include hydrogen. This is also positive one. And what else? Yeah, these are our common na mga elements, na mga ions. Class, take note. These are their oxidation states, or let's just call them charges na lang para mas dali. So take note. How do we identify the oxidation state or the charges of our elements? Actually, sa periodic table lang na siya, class. Maunang sa laboratory, gipabuhat mo og sarili ninyo nga periodic table para makasulat mo din ha. Para mas dali sa ato mag-identify og charges sa atong mga elements. Ang inyong tandaan, class, if they belong sa group 1A, they are all positive 1. Again, if they belong sa group 1A, they are all positive 1. Hydrogen, lithium, sodium, potassium, rubidium, cesium, even the francium, they are all positive 1. And then, even sa group 2A, apils beryllium din ha, silang tanan positive 2. Para pagpangutanon mo sa sunod, si charge ni magnesium. So, kabalo dapat mo nga, positive 2 siya kay it belongs sa group 2. And then later na ta mag-deal with the transition metals. Let's jump to group 3A. So atong group 3A po, they are all positive 3. Though ang nakabutang lang din ha sa inyong screen si aluminum kaya siya man pinaka-common sa ilaha. Nasundan pa? Nasundan pa nino?
Yes, ma'am.
Okay, now how about sa group 4? So group 4 can be positive 4 or negative 4. Depende siya sa carbon. Carbon behaves differently from other elements. So pwede siya positive 4, pwede siya negative 4 with exceptions. Kasi si tin ug si lead, naana siya na silang duha na belong na sila sa group 4A, pero they have multiple na charge or multiple ilahang oxidation state. Si tin can be positive 2. Sn is tin, di ba? Pwede siya positive 2, pwede siya positive 4. And then si lead, pwede po siya positive 2, pwede po siya positive 4. Again, walay magtawag ani og lead ha, kay lead na siya kung sa English na siya mag-lead ta og prayer. Pero kung element na siya, we pronounce that as lead. So mo na class nga walay magpagasolina og sakyanan mo ingon og unleaded ha. Kanang di ba na mga sakyanan no, paggasolina mo magpagasolina mo og unleaded. It's unleaded kay kana siya nga type sa gasolina, wala na siya lead. Mo nang gitawag siya unleaded. So lead na siya. And then pag-abot nato sa group 5A, ang charge ani nila mobalik ta sa negative 3. And pasunod na siya, group 6A is negative 2, so oxygen pababa. And then the halogens, the group 7A are negative 1. So ang group 8A, since sila lang ang nakakompleto sa octet rule, that is why they are called double gases. They don't really react with other elements to form compounds, so will not include them. Okay, so tagaan ta mog hint ngano na siya class ingana ilahang charge. So for example, you are familiar with the octet rule, di ba? So gani meaning ani?
Lang na valence electron ang kailangan, ma'am, para maging stable ang element.
Okay. So, mo ni siya ang kailangan na number of electrons para matawag natog stable ang elements. Pila to kabuo? Pila ka electrons to? Octet.
Ma'am, hindi mong microphone, ma'am.
Unsa? Ay, dili ko mabatian?
Hinay lang siya, ma'am.
Hinay, ma'am.
Wait lang. Ano man eh? So how about that? Can you hear me?
Apa, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Okay. So, again, we have 8 electrons class. Pag moingon kag octet rule, dapat na kompleto nila ng 8 electrons sa ilahang outermost shell. So, ani manggod niya siya, just like sa case ni sodium. Sodium ha. Sodium is 1123. Sodium is 1123. If we are asked about the subatomic particles, this one is 11, right? Yeah, wala ba ni charge, diba? So this is also 11. And then this is 23 minus 11 is 12. Tapos, ani ni siya. Para naamoy illustration. Sodium belongs sa period 3. Diba? Pag maingon kag period, it's the number of energy shells sa atuang element. So, kung sodium ni siya, this is the nucleus here, naana siya tatlo ka buok na energy shell where we can find the electrons. Tapos, pag moingon ka og octet rule, dapat kaning sa pinaka-last class, pinaka-last nga shell na ni, dapat 8 na kabuk iyahang electron. Pero what happened kay sodium? 11 man ni iyahang electrons class. Pag i-distribute na nato siya sa iyahang energy shell, dinha mo sulod tong inyuhang lesson tong high school nga electronic configuration. Diba ang electronic configuration magsugod sa 1s2? Can you still remember this?
Familiar na lang, ma'am.
Familiar na
ma'am.
lang, ikalimtan na ninyo.
Familiar na lang, ma'am.
Okay, tong high school mo na mo lesson aning electronic configuration na 1s2, 2s2, 2p6.
Yes, ma'am.
Okay. So ang meaning aning 1 dinhi mao na siya ang first energy shell niya. Meaning daw naa na siya duha ka electrons dinhi. So you have 1 and then 2. Tapos this 2 here refers to the second energy shell. So duha man is sila kabuok 2 and 6. So meaning na kay 8 kabuok sa second energy shell. 1, 2, 3, 4, 5, 6, 7, and 8. So, ang sunod ana 3. So sa third energy shell, pila na lang ang nabilin nga electron ni sodium?
Isa, ma'am.
Isa kay 11 lang, di ba? 11 lang iyang electron. So 2 plus 8 is 10, meaning sa iyahang outermost shell class naa na lang siya isa ka valence electron. Isa ka electron sa iyang outermost shell. Mao na siya class nga nabilong na si sodium diri sa group 1. Kay ang group class, the group represents the valence electron or ang electron class nga naa sa iyang outermost shell. So, kung ingani class na siya isa ka buok nga electron sa iyang outermost shell, stable ba si sodium or dili?
Unstable. Dili, ma'am.
Why? Ano dili man siya stable?
Nasubraan, ma'am.
Okay? Unsa dapat para mahimong stable, dapat na siya
8 electrons.
okay, very good. 8 electrons sa outermost shell. So, kasi buhaton ni sodium para mahimo siya stable. Sa tanaw ninyo buhaton ni sodium. Ang himuon ni sodium class, kaning isa ka electron niya, ihatag na niya. Meaning, i-transfer na niya sa uban nga element. Kasi it will be easier for sodium to give this, okay, to let go of this 1 electron kaysa sa mangita siya og 7 ka electron para mahimo siya og stable. So, ang ginahimo ni sodium, ihatag na lang niya ng isa. Kaya ang sunod niya nga, energy shell, 8 man kabuok ang electron. So, mahimo na siya og stable. So, ana na siya, ihatag na siya ni sodium, ang isa niya ka electron. So, ang mabilin class kay 10 na lang ka electron. Pero naa pa siya 11 ka protons, mao na nga positive 1 iyahang charge. So mo na siya class ang reason sa ilahang mga charges nganong positive 1, nganong positive 2, and so on. Questions so far? I-illustrate lang nako paano na nahimog positive 1 ang iyahang charge ha. But nevertheless, ang inyuha lang tandaan kung asa sila nabilong, mao na ang charge niya. Kung naa siya sa group 1A, positive 1 siya. Pag naa sa group 2A, positive 2, and so on. Pero paano ning nasa tunga? Kaning mga nasa tunga class, mga transition metals, mostly sa ilaha, positive 2. So wala kay mo'y daghang i-memorize pag abot sa transition Positive 2 na sila mostly. Naalang tayo mga exceptions. So we have there the chromium. Kay si chromium, Cr is chromium, duha ka buok iyahang charge. Pwede siya positive 2, pwede din positive 3. And then manganese also, the same thing with the iron, the cobalt, and even the nickel. Pareha silang tanan nga pwede positive 2, pwede pod positive 3. So if we write their name, class, we write their name as like this, like iron 2 or iron 3. This is how we write their names. Kay again, duha ka buok ang pwede niya nga oxidation state. Iron 2 or iron 3. That's the formal way according to IUPAC. IUPAC means International Union of Pure and Applied Chemistry. Sila ang nagahimo og rules and guidelines in naming and making the chemical formula. So pag mga elements again nga multiple ang charge, we write the charge after the name inside the open and closed parenthesis. Pero pag common name na siya, class, we will be using the ending na OUS and IC. So I hope you can still remember this sa inyong high school pod. Diba usahay ang element mag-end sa OUC, ang usahay mag-end pod sa IC. Applicable ni siya, class, sa mga elements nga naay duha ka charge. Ang OUS will be the lower charge and then the IC will be the higher charge. So pareha sa iron. Ang lower charge niya kay positive 2, so siya ang mag-end sa OUS. Pero wala to na siya ginatawag og ironous ha. We call this as ferrous. So let's go back to its Latin name. Ferrous atong tawagan na. Parehas anang ato ang ginainom nga iron supplement na ferrous sulfate. So di ba ang mga anemic dinhi kay ginapainom sa mama sa doktor og iron supplement. That's what we call ferrous sulfate. And ang meaning ana kay iron na siya nga ang iyahang oxidation state kay positive 2. Tapos, ang iyahang higher oxidation state, mag-end na siya sa IC. We call this as ferric. So again, we don't call them ironous o ionic ha. It's ferrous and ferric. So kanang OUS o IC nga ending sa name is also applicable to other elements nga naay dual nga charge. Parehas anang chromium. Si chromium positive 2 ug positive 3. Ang positive 2 pwede nato siya tawagon og chromium 2 or pwede pod chromous. Or si chromium 3 will be called chromic. Okay? Manganous and manganic, ferrous and ferric. Ang tandaan lang ninyo ang lower ang OUS, cobaltous and cobaltic. Ang nickel though is how do you call the nickel? I forgot the nickel. Let's go back with the nickel later. The copper is cuprous and the cupric. And then for gold, dili na siya goldic o goldus ha. It's aurus and auric. Mercury is mercurous and mercuric. And that is also true for this one, though they are not transition metals. This one is called stannous and stannic. And for the lead, plumbous and lambic. So iklaro na ko kanang OUS ug IC nga ending is applicable for elements nga duha ka buok ang oxidation state, ang charge. So ang lower nga oxidation state kay mag-end sa OUS, ang higher will end with the IC. But that is not actually the formal way of making the name. Ang formal way is this one. You write the name of the element like tin. So example tin, and then ibutang nimo tin 2 and tin 4. That's how we write the formal name of the element with their charge. Questions so far? We'll use this one later sa atong activity this afternoon. So make sure nga nakopya na ninyo. Okay? What time is it? We still have at least gamay na lang at time. Chemical, let's talk about the chemical formula. When you say chemical formula, it expresses the composition of molecules. Wait lang. And ionic compounds in terms of chemical symbols. Mo na itong ginatawag og chemical formula. So we have here two types of chemical formula, the molecular formula and the empirical formula. Sa kalahian na nila, when you say molecular formula, this will show us the exact number of atoms of each element in the smallest unit of a substance. So for example, maingon ka og water. Water is H2O. That's the molecular formula of water. It will give you how many atoms of hydrogen is there and how many atoms of oxygen also. So exact number of molecules. Or for example, we have the hydrogen peroxide. What is hydrogen peroxide again? H2O2. So again, pag maingon og molecular formula, exact number of atoms. So for hydrogen peroxide, you have there 2 atoms of hydrogen and 2 atoms of oxygen also. Molecular formula na siya. Pero pag ginatawag nato class og empirical formula, kung sa math pa na class, atuan na siyang gina-reduce to lowest form. So, di ba sa math ninyo, gina-ask mo, usahay, example sa fraction, ginapa-reduce to lowest form. Maupod na siya ang empirical formula. So, ang empirical formula will not really give you the exact number of atoms, kay simplest form man nato siya. So, kung sa water na siya, syempre si water, dili na nato ma-simplify kay 2:1 man. So, ang empirical formula ni water is the same thing, H2O. Pero si hydrogen peroxide, saan ganin ninyo pag-simplify class? Pareha sa mathematics, paano i-simplify ang mga numbers?
Factor nila, ma'am. Common factor.
Saan sa?
Common factor, ma'am. For example, kay
Sige, go.
2468. So, ilang common factor is 2. So, i-simplify siya.
So, i-simplify siya using their common factor. So, for example, tanawon ninyo si hydrogen peroxide, H2O2, what is their common factor? Ano sa common factor ani nila?
2.
2. So, ang himuon na class to get the empirical of hydrogen peroxide, we both divide this into 2. So, this becomes now HO. Ano siya ang empirical formula ni hydrogen peroxide. So, 2 divided by 2 is 1. So, H na lang, isa ka hydrogen, isa ka oxygen. So I hope nakita ninyo ang difference ni molecular formula ug ni empirical formula. Si molecular formula this is really the correct chemical formula because it will show you the definite and the exact numbers of atoms for each element. Pero pag moingon kag empirical formula, these are formula nga gina-reduce in lowest term. So we need, kung ma-reduce pa siya, i-reduce gyud siya parehas sa hydrogen peroxide. Kay parehas man sila 2, so pwede siya ilang common factor kay 2. Pag i-reduce nato, mahimo na lang na siya hydrogen and oxygen. Pero si water, the same lang iyahang molecular formula ug empirical formula kay dili naman nato siya ma-simplify. That's the difference between the two types of formula. So I think din ha sa ako mag-end, kay it's 11:55. We will continue our discussion next week after our quiz sa measurements. So mag-quiz ta sa Thursday og measurements. Tapos mag-continue ta sa atong discussion about the chemical formula. Any question? Laban na ito mga
None
bro.
so far po.
Okay. Ako aning isend sa inyo ha ang link class.